material is about 70 feet long. So this thing about 70 feet long, kind of hanging from a crane, half in, half out. Now the thing is, if the two materials were the same, you know, my little circle and the little ball here are the same material, right? They don't get in. But if I heated them together, and they both heat up, notice they'll get through. Which means, since they are the same material, they're expanding at the same rate. So what did that tell you about the turret, with the steel in the turret and steel in the gun barrel? Were they the same? No, they were different. They had a different expansion rates on that. So it does show that different materials will expand at different rates on that. So there's a case where knowing something about thermodynamics, they didn't take that into account. But I also want to talk about the hull. Because is the ball expanding when I heat it up? We showed that, right? But also, do you think if I measured the width of my ring, do you think it gets greater when I heat it up? The width of the metal part. Yeah. But notice, and you might think, well, it's kind of expanding in all directions. Wouldn't that mean the hole is getting smaller, right? Because it's expanding outward this way. It's going that way, but it's also expanding inward, right? But we can see that if they're heated together, the hole gets bigger. Question is why? Write down in your notes why you think the hole might be getting bigger. By the way, do not touch these. Even though they might look like they've cooled down, they haven't. Many hot things look just like cold things. Write down why you think it may be that it's getting bigger. I think those are made out of bronze, actually. Well, basically it's a demonstration thing. Just the bronze hoop, the bronze ball. I mean, it's a solid ball in a hoop. Now, we know that our ball is expanding. We know the hoop is expanding. And it's going to expand in all directions, right? If I took this section right here, I know it's expanding that way, it's expanding that way, it's expanding that way, expanding that way. It's expanding in all directions. And you might think, well, you know what? Then the hole should be getting smaller. By the way, this has nothing to do with expansion joints. That's a whole different issue. But we know it got bigger. Why? Well, what if we broke this into 4 sections? Like that. Now, as I heat it, it is going to expand in all directions a little bit. Remember we talked about the bridge, how the bridge, for every meter, it will expand a certain little bit. Same thing happens with volume. It's going to expand in all directions. So basically what's going to happen is this whole thing would get a little bigger in all directions. It's going to get a little bit bigger in all directions like that. And you might say, well, that shows it's getting bigger in the middle. But notice it moves 1 unit inward. But notice that at the gaps, how many units is it moving? This one moves 1 unit. That moves 1 unit. So basically, my diameter is increasing by 2 units. I'm moving 1 unit in, 1 unit out. But because the whole circle, if I went around the circle, is increasing by 2 units, it only goes in 1 unit, my hole is going to get bigger. In other words, the circle gets bigger more than it grows inward. And this is good because if I have my track, remember we use this stuff, these things. See, most of you probably don't know what this stuff is. You think, well, this is the track we use for all those little experiments we rolled the ball down. This is called channel. This is what you make window frames out of. In other words, the window runs in this track. Well, if in the summer this little gap got smaller, what would happen to your window? It wouldn't move. It wouldn't move. It gets stuck. Does that happen? Yeah. Well, then that case, like if you had a steel window and an aluminum frame, yeah, you might have issues. But if they should be both the same material. Usually you don't have that problem. Usually if they get stuck, it's for other reasons. It's not because it's expanding too much. Wooden frames get stuck because it has to do with heat and cooling. It has to do with water. They get water in them and expand. That's what happens to wooden windows and things like that. But that's what the channel does. And so on that. So write a little summary of what we talked about, things expanding, both our little thing about changing barrels on the New Jersey and our little circle there. All right, so let's talk another fact about unequal heating. And this is a device, you probably have a number of them in your house, probably don't even realize it. Because of specific heat capacity and some other factors, materials are going to expand and contract at different rates. We take advantage of that with a device called a bimetallic strip. And it is just like it sounds, it's two metals. Now, the one I have is just like the picture. We have brass on one side and iron on the other. Brass and iron expand at different rates. And because they expand at different rates, when it cools, it's going to bend. And when it heats up, it's going to bend. And remember, if you expand more, you are also going to contract more on that. So I take my bimetallic strip, and I run it in the flame, and it doesn't matter which side goes on, because it pretty much heats all the way through. But notice as it gets hot, it's spinning, and it's spinning away from the brass side, because the brass side expands more than the iron side. Where do you think you might find one of these in your home? In the kitchen. Where in the kitchen? Well, you might have it in a drawer. What? You might. Depends. There are applications you might find in a knife drawer. And as it's cool, it's going to straighten. Notice how it's cooling and it's straightening out again. On that. Now, where would you find this? Well, you'd probably find one in your oven. You would find one in your refrigerator. You might find one in your drawer because probably if you have a meat thermometer, many meat thermometers run with a bimetallic strip. You might find one in the hallway of your house where the thermostat is. Because that's basically what they are. These are thermostats. They are used as thermostats. Now, I'm not suggesting you go home and take apart your thermostat. All right? I'm sure your parents would not be happy if you did that. look inside the thermostats, this is, one for your heater is usually more accessible. Roman, you still with me? Okay. You'll see usually a coil in there, and that coil is the bimetallic strip. The little coil looks like a spring. It kind of does double duty. It acts as a spring, and it's that bimetallic strip on that. Now, this is an old thermostat. You probably won't see one like this too much anymore unless you have an older home. This is actually a mercury switch. The little silver blob in it is mercury. And what happens is this bimetallic strip heats and cools. It's going to cause this glass vial to tip over. And when it tips over, there's some electrical contacts. And when that blob of mercury gets over the contacts, it basically makes an electrical connection and starts whatever is hooked to it. This could be an air conditioner or a heater. I mean, where it depends on which side. It's like usually it's like the air conditioner switch is on one side and the heater switch is on the other side. That's why if you look on your controller, you have to either tell it, are we running air conditioning or are we running the heater? To tell which part of the circuit are you going to energize. And so the heater runs, our bimetallic strip is going to expand, and it's going to move to the other side, and a little blob of mercury slides to the other end, and it turns it off. And you usually don't see these anymore for the obvious reasons we don't like to have mercury in our houses, even though the government wants us to use mercury in our houses again because that's what all those little CFL lights are full of. So now you usually see just a contact. In other words, as that little thing is going back and forth, it's going to make contact on one side, make contact on the other. And this is how your heater, how your refrigerator knows to turn on and off. It has a little bimetallic strip. It's how your oven, if you watch the oven, it turns on, it turns off, it turns on, it turns off. That regulator. Usually like a little meat thermometer, something like that. It's going to have a bimetallic strip in it. As it heats up, it's going to cause that needle to move one way. And it's also a spring, so it brings it back when it cools off. So it's also, usually you have some sort of bimetallic strip in there running. So it's used for a lot of purposes on that. Questions? Now, remember, all substances do this. Expand as you add energy. If you add energy, you expand. If you remove energy, you contract, except water. Water. This is a unique property of water. I mean, I know of no other substance that does this. None. None. Even weird, bizarre substances. I've never heard of any other substance that does what water does here. And this is a property of water that, beyond any others, contributes to the earth not turning a big ice ball. Because solid water floats. It is the only substance that the solid floats on its liquid portion. I took solid gold and I drop it into liquid gold. Where is that solid piece of gold going to go? Right to the bottom. If I took a piece of styrofoam, and I'm talking you crunch it down so there's no air in it anymore, so I have a solid piece of styrofoam, I drop it into liquid styrofoam, right to the bottom. If I took nitrogen, and I have liquid nitrogen and solid nitrogen, and I drop that solid nitrogen into the liquid nitrogen, it's going to go right to the bottom. Water, dihydrogen oxide. Drop the solid in the liquid and it floats. It's going to float.